Hello and welcome to this video on carboxyl derivatives. My name is Ochem, and in this video we'll be predicting the products of acyl halide synthesis reactions. In an earlier video, acyl halides were described to be the most reactive of all of the carboxyl derivatives. This video will focus on how to synthesize acyl halides from carboxylic acids. This is a particularly important reaction to convert a less reactive carbonyl group to something much more reactive, so it will often function as one of a few steps in the overall reaction. Carboxylic acids will react with thionyl chloride to produce acyl chlorides, with hydrochloric acid and sulfur dioxide as side products. Briefly, the mechanism of action proceeds through the nucleophilic attack of the hydroxyl oxygen to produce an intermediate with the thionyl chloride. One of the chlorines are kicked off, which then attacks the carbonyl carbon at the same time the oxygen leaves. The end result is an acyl chloride, hydrochloric acid, and sulfur dioxide. Ultimately, the in-depth mechanism is not as important as recognizing that thionyl chloride will create acyl chlorides from carboxylic acids. Carboxylic acids can also react with phosphorus tribromide to produce acyl bromide and dibromophosphonous acid. The mechanism of action is similar to that of thionyl chloride. The lone pair on the hydroxyoxygen will attack the phosphate, kicking off a bromine. The bromide will go back and attack the carbonyl carbon, which kicks off the leaving group to form acyl bromide. Interestingly, another carboxylic acid can attack the dibromophosphonous acid and become acyl bromide until all three bromine atoms are transferred, which is why the net reaction are three carboxylic acids reacting with one phosphorus tribromide to produce three acyl bromides and phosphorus acid. The applied question asks for the product of the following reactions. The first reaction is propanoic acid reacting with thionyl chloride. The thionyl chloride will swap out the chlorine for the hydroxy group, and the product of this reaction will be propyl chloride, hydrochloric acid, and sulfur dioxide. The next part of the applied question has three equivalents of acetic acid reacting with phosphorus tribromide. Let's consider each individual step. One acetic acid will react with phosphorus tribromide to produce acetyl bromide and dibromophosphonous acid. Another acetic acid will come and react with a dibromophosphonous acid to produce acetyl bromide and a phosphate with only one bromine left. Finally, one last equivalent of acetic acid will grab the remaining bromine to produce acetyl bromide and phosphorus acid. Let's make sure everything is accounted for. 1, 2, 3 equivalents of acetic acid produces 1, 2, 3 equivalents of acetyl bromide and 1 phosphorus acid. Now that you understand the underlying mechanism behind how a carboxylic acid can be transformed into an acyl chloride or an acyl bromide, you can now follow up with some practice questions.